Hi guys, today we're going to talk about how to write equations of parabolas in the standard form that we discussed in the previous day's notes. Now just a reminder, and I've got a graph here for us, just a reminder of some of the vocabulary that we learned yesterday and what it refers to as a key feature on the graph of the parabola. So let's say that a parabola has a vertex here. The focus would be a point that's inside of the parabola. So perhaps my parabola opens up. This would be my focus. And then my directrix would be on the other side of the vertex, the same distance away as the vertex is from the focus. So 1, 2, 1, 2. This is my directrix, my line. And then the focal chord is a line segment that goes through the focus, and its endpoints are on the parabola. So my focal chord will be 2 units this way and 2 units this way, and here is the line segment that is my focal chord. And my parabola goes from the vertex to the endpoints of the focal chord. So yesterday, this is what we did to graph. My parabolas could open up. They could also open down. And then we also talked about parabolas opening side to side. So horizontal parabolas can either open to the right or they can open to the left. And the difference is the location of the x and y variables in that standard form. So if the parabola is horizontal and it's opening to the side, either side, then your y value is what's being squared, your y variable. So today, we're going to call upon that vocabulary that was new yesterday, and we're going to talk about, instead of how to graph the parabolas, we're going to talk about how to write equations of the parabolas in that new standard form. And remember, that new standard form, there were 2 standard forms. One standard form when the parabola opens up or down, and one standard form when the parabola opens side to side, so vertical and horizontal. Today we're going to convert each equation that we're given into one of those standard forms by completing the square. We want to be sure to label the direction that the parabola opens. So up, down, left, or right. We want to make sure we label the vertex, find the p-value, can locate the focus, and the directrix. So all of those key features we learned about in the previous sets of notes, we want to make sure that we can identify. So in an example, like example 1, we have this relatively long equation, 2x squared plus 16y plus 8y minus 8 equals 0. And maybe your first thought might be to solve for y, but we're not going to do that here because what we want is standard form. So just revisiting my notes from yesterday, and this is my key for the notes from yesterday, we had 2 kinds of standard form. We had standard form for vertical parabolas that looked like this, and standard form for horizontal parabolas that looked like this, with the x and h and y and k variables kind of switched in each form. In standard form for a vertical parabola, the x is being squared, and in standard form for a horizontal parabola, the y is being squared. So it needs to end up looking like one of these. So the first thing that we want to do is we want to divide all the terms by the coefficient of the squared term. Because in standard form, the squared term has no numbers out in front. It's just x minus a number, and that quantity is squared. There's no coefficient. So I need to make sure I get rid of the coefficient of the squared term by dividing by it. So I'm going to go divide all of my terms by the coefficient of the squared term. Well, the x squared is here, and the coefficient is 2. So I'm going to divide every term, even that 0, by 2. And of course, 0 divided by 2 is still 0. So if I do that, I have x squared, I have plus 8y, I have plus 4x, I have minus 4, and I have equals 0. So I've divided all my terms by the coefficient of the squared term. Now, step 2 says the squared term with the same variable term should be on the left side of the equation. Move the other variable and the constant to the right side. So here, my x is the squared term. My x squared is that squared term. So that means that I'm trying to get my equation to look like this. That means anything that has an x needs to be on the left side of the equation, and anything with a y or a constant needs to go on the right side. So I'm going to make sure that my x squared and my x term are on the left side, and my y term and my constants are on the right side. So here's my equal sign. My x squared and my 4x term are already on the left side, but my y term and my constant need to be moved over here. So I'm going to subtract 8y and subtract 8y, and I'm going to add 4 and add 4. So I have x squared plus that 4x. I'm going to leave a little space because the next step is going to be to complete the square. And then 0 minus 8y is negative 8y, and then plus 4. So we moved the squared term and its same variable term on the left, and we moved the other variable and the constant to the right. Now, I need to complete the square for the left side with the squared term and add that value that completes the square to both sides of the equation, just like we typically do when we complete the square. And the reason that we're completing the square is because completing the square gives us x plus or minus something and then squared. It gives us a binomial squared. And so when we complete the square, that's our goal, is to get something that looks like this on the left side. Because remember, we want to write our equation in standard form. We want it to look like this. So we're going to complete our square to get a binomial squared on the left side. So if I complete the square, I'm going to take my b number, my b term. I'm going to divide it by 2 and do what to it? Square it. 4 divided by 2 is 2. 2 squared is 4. So 4 is what completes my square. I'm going to add 4 to both sides of my equation. Now, when I factor this perfect square trinomial, I get a binomial squared. The square root of x squared is x. The square root of 4 squared, the square root of 4 is 2, and I'm using the positive value. And then the right side, I have negative 8y plus 4, so plus 8. So we're getting awfully close to that standard form. The only thing that we don't have, because we have the x minus h squared, but we don't have 4p times y minus k. We don't have the parentheses over here. And so the last thing that we need to do is we need to, we place the left side in factored form. We need to factor out a GCF on the right side. That way we have something outside of parentheses and then y plus or minus something inside of parentheses. So if I factor out a GCF, well, 8 is the GCF, and I don't want my leading coefficient to be negative, so I'm going to divide out the negative 8. So I have x plus 2 squared equals, the negative 8 comes out. Negative 8y over negative 8 is just y. 8 over negative 8 is minus 1, and I close my parenthesis. And that looks exactly like it's supposed to in standard form. So now I'm going to go identify all of the information, remembering that h is always with the variable x, k is always with the variable y, p is here, but you'll have to take that number and divide it by 4 to get the actual p value. And then we'll kind of put together those pieces to find the focus, directrix, and focal chord. So standard form is x plus 2 squared, and that equals negative 8 times y minus 1. Now, the x is squared, so this is a vertical parabola. This 4p value is negative though, so does it open up or down? opens down. The vertex is h comma k. H is right here, but I changed the sign, so -2. K is right here, but I changed the sign, so it's +1. The p value comes from this. If 4p is -8, then in order to solve for p, I need to divide by 4. So p is equal to -2. Now the focus is an ordered pair. We learned from our notes in the previous lesson that the focus is h comma k plus p. So I'm going to go write h comma k plus p. My h value is -2. K is 1, p is -2, so 1 plus -2 is -1. The directrix is y equals k minus p. So I'm going to go put together k minus p. K is 1, p is -2. So if I do 1 minus -2, that's really 1 plus 2, and that's 3. So there's all of my pieces of this parabola. So let's move to example 2. Example 2, what's being squared? The y is being squared. So how does this open? Is it horizontal or is it vertical? It's definitely horizontal, but we don't know if it opens to the left or to the right yet. So let's go ahead and go through our steps. First step was to divide all terms by the coefficient of the squared term. Well, here's the squared term. What's the coefficient? It's 1, so we don't need to divide by 1. That won't do anything. Next, we need to move the squared term and its same variable term to the left side, and then the other variable and the constant to the right. So we're going to move this minus 8x, and we're going to move this minus 7. So we have y squared minus 6y. I'm going to have a space. And then we have 8x plus 7 with another space. Next step, complete the square so that I get a binomial squared over here. So I'm going to take that middle term. -6 divided by 2 is -3. And if I take -3 and I square it, I get 9. So 9 is what completes the square and what I should add in on both sides. So my binomial squared, once I factor, the square root of y squared is y. The square root of 9 is plus or minus 3, but I need to use -3. I have 8x plus 9 and 7, so plus 16. And now I need to take out my 4p right here. I need to take out my greatest common factor. So both of these are divisible by 8. And I have y minus 3 squared equals 8 times x plus 2. So there's my standard form. I notice that 8 is positive. So if this is a horizontal parabola and it opens in the positive direction, that's opening to the right. My vertex, h comma k, h is with x, so the opposite of 2 is -2. K is with y, so the opposite of -3 is +3. P comes from right here, so if 4p has 8 in its place, then when I divide by 4, I get a p value of 2. My focus from my notes yesterday, looking at the horizontal parabolas, the focus is h plus p comma k. So h plus p comma k. H is -2, p is 2, so if I add them together, I get 0. K is 3. And my directrix is x equals h minus p. X equals h minus p. So x equals, h is negative 2, minus p, which is 2. So if I have negative 2 and I subtract 2 more, I get negative 4. So keep in mind that when you have a directrix that's x equals something, that means that this is a vertical line. And if your directrix is vertical, that means that your parabola is opening horizontally. It's either right or left. So I'd like for you to take a moment to look at example 3. What's being squared, x or y? Y is being squared, so it's going to open horizontally. I need to divide all of my pieces, all of my terms, by the coefficient of the squared term, which is 4. So I'm going to go ahead and do that, and then we're going to see if you can finish some things. So when you divide by 4, you get y squared minus 8y plus 12x minus 20 equals 0. I need these two things to stay here and these two things to move. If I move a positive 12x, that's going to be a negative 12x on the other side. If I move a minus 20, it's going to be a positive 20 on the other side. So I'd like for you to pause your video and try to complete the square and finish writing standard form. So check your work with mine. 16 completes the square, but the factored form is y minus 4 squared. And then if you take out a GCF from the right side, negative 12 should be in place of 4p. So because this is negative, but it's a horizontal parabola, it's opening in the negative direction, that's to the left. I want you to try to find your vertex, p-value, focus, and directrix, and you might need to refer to your notes from the previous day for those two. So pause your video and try to find the rest of the key features. So check all of your work, check your p-value, focus, and directrix. Okay, so our last page of notes today asks you to write the equation of the following parabolas with the given information. So in example 4, it says, what is the equation of the quadratic function with a focus at 2, 4 and a vertex at 2, 2? So my vertex, 2, 2, has my h and k. Well, I notice that in my focus, the h here is the same here. So that means that my focus has a k plus p value for the 4. And so I'm going to go look and I'm going to see if this matches with a vertical parabola or a horizontal parabola. So if I look at my standard forms, here my focus is h plus p comma k, so my h would be different, but here my focus is h comma k plus p. So that means that my parabola is opening in the vertical direction, and I should follow this information. My directrix will be y equals k minus p. So here, if k is 2 and k plus p is 4, well then p has to be 2, right? P has to be 2. So if I'm looking for the quadratic equation in standard form, well, h would be 2, and p would be 2, and k would be 2. So my quadratic equation is x minus 2 squared equals 4 times 2, that's 8, times y minus 2. And if I plot this, my vertex is at 2, 2. My focus is at 2, 4. The directrix is the same distance away from the vertex as the focus is, just in the other direction. So 1, 2, 1, 2. Here is my directrix. And my focal chord is 8 units long. So that's 4 units in each direction. So 4 units this way, 1, 2, 3, 4. 4 units this way, 1, 2, 3, 4. So here's my focal chord. And I'm going to connect my vertex to the endpoints of my focal chord. Okay, so let's see what number 5 gives us. Number 5 gives us a vertex, H and K, and it gives us a focus. Well, the only thing that's the same is not H, but K. So that means that this must be H plus P. That also means that I should be using this information, that my parabola should be opening horizontally, and that y should be squared when I write my equation. So, if h plus p is equal to 6, and h is 1, well, what does p have to be?
Exit the building. Please exit